Okay, today we're in lesson 6.3, comparing functions. Lesson 6.3, comparing functions. Please get the section number and the title in your notes. Get the section number and title in your notes. 6.3, comparing functions.
You know, functions come to us in a variety of different shapes and forms. We can look at them graphically. We can look at them in terms of a table with a bunch of numbers showing the function, or we could see an equation for a function. And there's lots of ways of taking different functions and comparing them. And we can even compare different functions when they're given to us in these different modes. And so what I want us to do is to actually take a look at some of these. And the first one is given to us by parking in a garage. Can you imagine a more exciting thing? Unfortunately, I cannot. Here we go. So, the table and the graph show the hourly charges for two parking garages. And our mission is to compare the charges by finding slopes and y-intercepts and interpreting these values in the context of the situation. So, in both cases, we're looking at linear information. And in the first case, in garage A, we're given that linear information in terms of a table of values. So, for the hours that we would park our car, this refers to the charges. And with garage B, the data is given to us by a graph, and you can see the linear expression is given to us by a line, obviously. So now what I want us to do is to analyze different features of this. So the first thing I want to analyze is just the y-intercepts, where in fact the line of data actually crosses the y-axis. So it's really easy to do that in garage B. You can see it because here's the y-axis, and you can see where it crosses, right exactly between 6 and 8, which means 7. So that means that when you drive into the parking lot, if you were to be there for 0 up to an hour, then you're going to be spending $7. $7 is what you pay. Now, what about using the chart information to look at garage A? Well, that's given to us by time 0, because remember that the y-intercept happens exactly when x is 0, and this is representing the x values, these represent the y values. So when x equals 0, y is 5, and so I see a y-intercept here for garage A of $5. So the way we interpret that is by saying, if we're staying in the garage for a very, very short period of time, then in fact we pay more in garage B, namely $7 versus garage A where we pay $5. So if we're under an hour, we really would, go with garage A rather than B. Okay, now let's take a look at the slopes. So how do we figure out the slopes of these lines? Well, if we look at the graphic, it's easy because remember it's rise over run. So all you do is take a look at the change in the y over the change in the x. Now the change in the y, for example, this point to this point here, is 1 unit. And the change in the x, you can see again, is 1 unit. So this is 1 over 1. This has a slope of 1. So this line has slope 1. And what about the slope here? Well, here, it's not a visual thing, so we actually have to compute. We actually have to compute this by looking at the change in y over the change in x. So I'll just pick these 2 points here. So 7 minus 5 is 2. 1 minus 0 is 1. So it's 2 over 1. This is a slope of 2. So this is a steeper slope, right? The slope is greater. So what that means is that the rates of charge actually are increasing faster with garage A than with garage B. That's how we'd interpret that. So it's kind of cool that the slope tells us how things are changing and the y-intercepts tell us where we're starting.
Okay, now a couple of things to take note of that maybe he didn't do a good job of explaining in great detail. 1, notice that the y-intercept here is 7. Now the y-intercept is at 7 when x is at 0. See here? X is at 0 and the y-intercept is 7. Here, when x is 0, that's the time, when x is 0, the y-intercept is 5. Now what that means is, that means that before you even step into the garage, if you're going to go in there, when you first go in there at time 0, you already got to pay them $7. Here, at time 0, you got to pay them $5. Now notice from previous lessons that here the line is linear, but because it's not going through at 0, because it's not going through at 0, 0, or the y-intercept is not 0, we say that this line is linear, but it's non-proportional. It's going to be the same with this one because the y-intercept is 5. The y-intercept is not 0. So this is also going to be linear and non-proportional, as opposed to being linear and proportional if it were going through at 0. Comparing a table and an equation. To compare a function written as an equation and another function represented by a table, find the equation for the function in the table. Example 1. Josh and Maggie buy MP3 files from different music services. The monthly cost, Y, dollars, for X songs is linear. The cost of Josh's service is Y is equal to 0.50x plus 10. The cost of Maggie's service is shown below. All right, now for Maggie's service, we see 5 songs would cost her $4.95, 10 songs, $9.90, 15 songs, $14.85, 20 songs, $19.80, 25 songs, $24.75. Step A, write an equation to represent the monthly cost of Maggie's service. Step 1, choose any 2 ordered pairs from the table to find the slope. And don't forget, slope is equal to y sub 2 minus y sub 1 over x of 2 minus x of 1. So the y2 value that they picked was $9.90. The y1 value ends up being $4.95. So we're going to divide that by the x2 value, which is 10, and the x1 value, which is 5. So $9.90 minus $4.95 is equal to $4.95. 10 minus 5 is equal to 5. So $4.95 divided by 5 is equal to 99 cents. Step 2, find the y-intercept. Use the slope, which we just found, and any point. Once again, step 2, find the y-intercept. Use the slope and any point. We just found the slope as being 0.99. So we're going to use the slope-intercept formula, y equals mx plus b. We just determined that m was 0.99. Now we're going to pick any point from the table to use. You always try to pick the easiest point to work with. Now the smallest numbers in this case happen to be 5 and 4.95. So that's our point. X is 5 and y is $4.95. So in place of x, we're going to put 5. In place of x, they put a 5. M, that was our slope, that was 99 cents. And the y value was $4.95. So now we have $4.95 is equal to 0.99 times 5 plus b. So now we end up multiplying 0.99 times 5 and then subtracting that from both sides. All right, now for those of us who are still having difficulty solving equations, I'm going to take this equation, and put it up here. So now I got 4.95 is equal to 0.99 times 5 plus b. Now 0.99 times 5 would give me 4.95. 0.99 times 5 is 4.95. So now I have 4.95 is equal to 4.95 plus b. I want to get the b by itself. So this right here says a positive 0.495. So to get rid of it, I must do its opposite. Opposite of a positive is a negative. So I'm going to say minus 4.95 on one side and then minus 4.95 on the other side. Don't forget, whatever you do to one side on an equation, you must do the same thing to the other side. So now 4.95 minus 4.95, that goes to 0, so that's gone. So I'm just left with b. And then 4.95 minus 4.95, like we said, is also 0. So at this point, b is equal to 0. Now, since we know that b is equal to 0, we substitute the slope and y-intercept back into our original equation. So we know that y equals 0.99 times x, and we determined that b was 0. So since b is 0, 0.99x plus 0 is equal to 0.99x. So y is equal to 0.99x. So now we can determine which service is cheaper when 30 songs are downloaded. So we know one equation for Josh, and we know the new equation that we just figured out for Maddie. So now we put in 30. So we get y is equal to 0.50 times 30 plus 10. 0.50 times 30 plus 10 will come out to be 25. Maggie's service, y equals 0.99 times 30, right, because it's 30 songs. That's going to end up being 29.7. So you can see that Josh has the cheaper or the less expensive service. Now bear in mind, when you're doing your math here, you can actually do the math in your head. 0.50 means a half. So half of 30 is 15. 15 plus 10 is 25. All right, that concludes our lesson for today. So let's go ahead and get started.